Hi, hello, my name is AHMAD. We have GAFFOOR. Okay, today I would like to explain about this question on solve the differential equation and proving the constant value of C and and determine the current value of I at t equals to 1. Okay, first of all, step 1 is that when you substitute the given value into the differential equation, di over dt plus 15I equals to 110 sin bracket 120 pi t. Next, you solve the differential equation using the method of integrating factor. IF equals to exponent integrate 15 over 3 dt equals to exponent 5t. Okay, for the second step is that multiply the both side of the equation with v bracket t. So di over dt exponent to the 5t plus 5I bracket exponent 5t then equals 110 in bracket exponent 5t sin 120 pi t. Then d over dt, when you rearrange it and you simplify it, equals to 110 exponent 5t, and don't forget sin 120 pi t. Then next is that you integrate both sides of the equation when you that is on rearrange it from the multiplication of the both side equation. So then you get exponent 5t I plus C1. C1 is the constant equals 110 over 3 integrate exponent 5t sin 120 pi t dt. Okay, next step is that using the IVP, that is integration by part. So you sub into this equation, but first of all you label it u equals to sin 120 pi t, and then you differentiate it, you get cos and times 120 pi t. Then dv is equals to exponent 5t. Then v equals to exponent 5t over 5. Then after you solve this u and du, then you sub into the equation. When you sub into the equation, you get this. Then you rearrange and simplify it. You will get exponent 5t over 5 sine 120 pi t minus 24 pi integrate exponent 5t times cos 120 pi t dt. But the most important thing, do not make careless mistake on the IBP. For the next part, so you should let integrate b equals to integrate exponent 5t cos 120 pi t dt. So when you let integrate b, then you write write the equation what you have done with the IBP. Then by using the by part again, integrate b equals to, you write the equation of the IBP. Then then you sub into the equation. But first of all, do not make mistake on the labeling on u and the dv. So u equals to cos, then you differentiate it, you get negative sign 120 pi t times 120 pi t. Then dv is equals to exponent 5t, v equals to exponent 5t over 5. Then you rearrange it, you get exponent 5t over 5 cos 120 pi t plus 24 pi integrate exponent 5t sine 120 pi t.
So since we set initial integral, which is for the equation integral e to the power 5t sine times 120 pi t dt, we can do this equation to the both side, which is we can use the left hand side and also right hand side, and we can get the equation such as the shown on the slide. So after we get the left hand side and also right hand side, we have to equal the left hand side equal to right hand side as shown on the slide. And after that, we have to substitute integral e to the power of 5t sine times 120 pi t dt into the equation, and it will be like this. And we will get e to the power of 5t I equal to 22 over 3 times with exponent e to the power of 5t times sine 120 pi t minus 24 pi cos times 120 pi t over 1 plus 576 pi square and plus c. After we already get that equation, we can substitute the value when I is equal to 0 and also t is equal to 0. It will be like e to the power of 5 times t times 0 equal to 22 over 3 times e to the power of 5t sine 120 times 0 minus 24 pi cos 120 pi times 0 equal over 1 plus 576 pi 2 pi square and plus c. And after we substitute all of this and we make a ways to have that answer, it can be proven, which is c equal to 22 over 3 times 24 pi over 1 plus 576 pi square. So this equation is proven. Thank you.
Alright, so hi, my name is No. So now I'm going to explain and guide you all on question 2. So how to solve this kind of question. So first, let's read the question. A stone ascends vertically from the ground level, subject to air resistance represented by the expression kV squared g meter per second square, where v denotes the stone's velocity in meter per second, k is a constant, and g represents the gravitational constant. Given that an initial velocity of the stone is u, so now we have to determine the maximum height achieved by the stone. And in this kind of question, we are going to use Newton's second law, which is given by E equals negative kv squared g minus g. So let's see what's actually happening in this situation. So as we can see here, the situation is like we throw upwards the stone, okay? So vertically. So we throw the stone vertically so that we are going to find the maximum height that the stone can achieve, right? While we still consider the air resistance there because we are not in vacuum space. All right. So next, next. So from the question, we need to look at all the information given. So all the information uh, will will help us to find the answer and to solve this problem. So for example here, the most important information that we can get is that the acceleration and also the velocity of the stone. So the acceleration is given by the Newton's second law, which is A equals to the negative k v squared g minus g, and also the velocity. And we note that we have the initial velocity. We denoted that the initial velocity is u, and also other information that we can get from this kind of question is that we need to apply what we have learned before. So we do some modification and we apply all what we have learned before. So we know that velocity is equal to dy dt, which is the rate of change of displacement with time. So here the displacement we refer to the height of the stone, okay, the height of the stone when we throw the stone upwards. And here we can have the acceleration, which is a acceleration equals dv dt, which is the rate of change of velocity with time. So here as we can see at the velocity v equals to dy dt, so we assume that y is the height, okay, we refer to height. And then so now let's look at the problem, uh, and let's generate some ideas on how to solve this kind of question. So the strategy or the plan here is that first we need to, by using the information given like the acceleration and velocity, so the acceleration given by the negative k v squared g minus g, and also we have at the modification we did just now, we have acceleration which is a equals to dv dt, and also we have the velocity equals dy dt. So why we need this kind of information? So this information we need in order to modify a equals to negative k v squared g minus g. We want to modify a, we want to substitute a with something in order to make the equation just be in terms of v and y only. We don't want t and whatnot. So here uh, we are going to modify a by using these three information that we got just now. And the second step, we are going to integrate both sides of the equation that we got from A. Next, the last step is that we are going to find the maximum height. We let y maximum, which is the height, the highest the highest height, yeah, the maximum height here. So, in order to find the maximum height of the stone achieved, so we need to make sure that the value of velocity, which is v, must be equal to 0. Okay, and the value v equals to 0 is going to be substituted into the answer that we got from b. Okay, so that's the general idea that we get in order to solve this question. So let's go to the solution step. So the solution here, okay, so from a equals to negative k v squared g minus g, and also a equals to dv dt, and v equals to dy dt. So here we modify a by applying chain rule and also substitution method. Okay, so as we know a equals to dv dt, dv dt is a product of dv dy times dy dt by chain rule. So we know, okay, so and then dv dy times dy dt equals dv dy times v. How did we get v? V equals to dy dt. So we substitute v equals to dy dt into dy dt, then we get v, right? So now we have a equals to dv dy times v, which is not in terms of t. So it's already fine, and we want to substitute it by substitution. We want to substitute it in a equals to negative k v squared g minus g. So we substitute a with dv dy times v. So then we rearrange the equation in to alike terms. So as we can see here, let the v terms at the left and also the y terms at the right hand side. So by simple algebraic knowledge here, so we can get the new arrangement. So what we are going to do? Next, the next step is that we need to integrate both sides of the equation. Okay, so the equation that we rearrange properly before, we need to integrate both sides, the left hand side and also the right hand side. But we must note that the initial velocity given by the question is equal to u, and we know generally initial height must be 0. It starts from 0 lah. Okay, and we assume that y as height. So the integration process would be like this, as stated on the screen here. So we integrate v over kv squared plus 1 in terms of v from u to v. All right, so that's going to be for the left hand side integration. And what about the right hand side? Right hand side, we integrate negative g in terms of y from 0 to y. So as we can see from these integrations, we can see that the right hand side would be easier to solve, but not the left hand side. The left hand side, we need to do some work, more work to do. We need to use substitution method of integration in order to solve it, because we cannot solve this part uh, directly. All right. So the step for integration and to continue to the last part to solve this equation. So let's jump to our next person in order to explain this. All right. Thank you.
Hi everyone, my name is RICKO JOHON. So today I will continue the next step, which is use substitution to solve this integration, which is integrate by limit of v is equal to v over kv square plus 1 dv. So first step we need to do is we let u is equal to kv square, where du over dv is equal to 2 kv. So next, DVE as the um, equal to du of 2 kV. So this dV we will substitute in back into the equations. So from the equations, so we integrate v limit integrate with the limit vu is v over u plus 1 times just du over 2 kv, so it's equal to negative integrate limit y 0 g dy. So next 2 over 2 1 over 2k integrate by the limit of vu, where v over u plus 1 times with du over v. So it's equal to negative gy with the limit of y 0. Next is 1 over 2k with the limit of vu 1 over u plus 1 du is equal to negative gy. So 1 over 2k, we integrate the limit of vu 1 over u plus 1. So we got ln u plus 1 with the limit of b and u. So don't forget the limit, okay? So next is 1 over 2k, we substitute u with the kv square. So we get ln kv square plus u, and with the limit of bu is equal to negative gy. So next, 1 over 2k, where ln kv square plus 1 mm, uh, uh, sub, uh, sub, uh, we subtract with ln ku square plus 1 is equal to negative gy. So we get the ln kv square plus 1. We factorize ln. Okay, we factorize ln. So we have ln kv square plus 1 over ku square plus 1 is equal to negative 2 kgy. Next, at the max height is v is equal to 0. That is from the questions. So we substitute a v with 0. So ln k0 square plus 1 over ku square plus 1 is equal to negative 2 kgy. So ln 1 over ku square plus 1 is equal to negative 2 kgy. So we separate, sub we multiply ln into the 1 and also the ku square plus 1. So we got ln 1, negative ln ku square plus 1 is equal to negative 2 kgy. So next we got ln ku square plus 1 and negative and equal to 2 kgy, where y is equal to 1 over 2 kg, ln ku square plus 1. So therefore, the maximum height is 1 over 2 kg, ln ku square plus 1, when the a is equal to negative kb square g y. So that is the last step and the answer for the question number 2. Thank you.